So grade 11s, I've made this just an optional one because I'm sure some of you, well then you're not watching the video, might have just preferred to read through it. So I didn't want to make it another ed puzzle, but let's try and engage as much as we can. So this is on page 210. So I just thought maybe it's worthwhile having a video, but hey, let me know. If nobody lets me know anything, then I know nobody's watched the video and it wasn't worthwhile. But we're going through this example. Using this identity, solve sine theta equals 3 cos theta. Now I'm going to change this question slightly from the textbook to say, let's say we were just given this. Solve for sine theta equals 3 cos theta. That's going to be our step 1. We're going to find a general solution and then we're going to add in where it is. You're not normally told using the identity. So I don't want to cross it out to say that's wrong, but you're not told this part. You need to know that. And this might be part B of the question. So let's call that part B, and this is part A, and this you're not told. Okay, so sine theta equals 3 cos theta. Now initially this looks quite daunting, like nothing we've done before. But it does look like so we can turn it into something we've done before. And notice that we seem to be using this strategy quite a bit in this section where we started with our cast diagram. I mean, that was we had some functions to start with and drawing them, but the heart of what we did was back to that cast diagram, and we're going back and back, and we're turning things back into what we've done before. So enough rambling. What are we going to do then? What are you on about? What can we do? Well, it tells us about this identity that we're pretending we're not told about. So we could, if we see sine and cos, we know that sine over cos is tan. So if we divided both sides, which we can legitimately do, by cos theta, what you do on one side, you do on the other, then what's convenient is one term of one term. So those cancel nicely. So on the right-hand side, we just got equals 3. But wait a second, sine theta over cos theta. Looks like we've made it more complicated, except our first trig identity is tan theta equals sine theta over cos theta. You've already got this written down because that's your starting point when you're dealing with identities. You know this one, and we also know sine squared theta plus cos squared theta equals 1, and the two variations on that. 1 minus, which we're not going to need for this question. But sine theta over cos theta, this is just tan theta. Now here's a question that looks like we've solved before. Tan theta equals 3. Okay, we're doing this as a general solution to start with. So we're going to go, let's start with our reference angle. Reference angle is what we what we informally call shift tan 3. So on our calculator, I don't have Brendan's calculator handy, sorry. So I'm going to do it on my calculator. Shift tan 3, 71,565. I'm going to go 71,6. I'm going to go to 1 decimal place. So if that's our reference angle, and we're not far from done, although we've done most of the hard work, Cartesian plane, just a little scrap Cartesian plane. I'm adding my xy's. We know it cast, C-A-S-T. We're given our reference angle is over here, 71,6. And tan we were given is positive. So this part here says tan is positive. So therefore, this is one of our solutions in A for all. So therefore, our one option for theta is 71,6 because tan is positive. Where else is tan positive? Well, there it is in the Edpuzzle version, quadrant 3. So therefore, if that's 71.6 would reflect. So 71,6. Life's easy when we're doing this because we're just getting to the x-axis. Don't have to worry about 90 pluses and minuses. So that's the one option of theta, or theta equals, well, if that's 180, we must add another 180. Let me actually show. I notice I say this step, but I don't always write it down, so it'd be nice to show that. plus 180 equals 251,6. So there are two values of theta. Now this one here, so for our general solution, I don't know why, let's type it out. So for our general solution, we can actually write, well, for what color? Blue. Theta equals, so the one option is theta equals 71,6. Oh, just add 360k. And our other option is or theta equals this other option, 251,6 plus k times 360. Okay, wasn't too bad. The key was in this dividing by cos, and then we turned it into an equation that we've seen before. Equation, function, I'd say equation because we're solving it here. So there are two options. Then we could look at, okay, if it asks us for theta to be in a particular range, so here it said theta is between 0 and 360, then we could sub in our values of k to make this work, and in which case there are only two solutions, 71,6 or 251,6. These would be our two solutions because those are the only ones within that range. But it could easily have asked us what happens if theta is between negative 360 and 360. Then you just substitute in for k for that range. But our starting point is general solution. So there we go. That's example 1 on page 210. Let me know if it was helpful to have a video version of it.